Hey there, Mr. Weaver here, and this is Geometry Lesson 8, Dilations and Similarity. After this lesson, you need to be able to draw a shape after it has been dilated from a specific point, and you need to be able to determine unknown lengths of similar figures. You'll know you're successful after this lesson if you can draw a dilated shape and calculate unknown side lengths of similar figures. In the last lesson, we learned about rigid transformations, our translations, rotations, and reflections. In this lesson, we're going to be looking at a transformation that is not rigid because it changes the size. It's called a dilation. So a dilation is a transformation that enlarges or reduces a figure. So it's making it larger or smaller. The shape is going to look the same as it did before, just a different size. When we're doing dilations, you're going to need to know the center of dilation. It's a fixed point from where all the points on the shape are either expanded or contracted. You're also going to need to know scale factor, which is the ratio that you're using to enlarge or reduce similar figures. And another word you're going to see is similarity. So similarity is when one shape can become another using resizing or dilation. So similar figures are just the same shape, but one is a dilation of the other. Let's look at some examples of how this works. Find the dilation of a quadrilateral ABCD with center P and a scale factor of 2. So what this means is we're going to use P and everything is going to be expanded out from that. So to do this, you are going to lightly draw a line from P through each vertex or corner of the shape. So here I lightly drew a line from P through A and kept it going for a little bit, and then from P through B, and then through C and D. Those are the imaginary lines that we're going to expand our shape on. We also see that it has a scale factor of 2. This means that every point on the shape is now going to be 2 times as far away from point P. So originally, A was about that far from point P. So it kind of cut across diagonally 2 boxes. Now we need it to be twice as far. So I'm going to do that again. I just cut across 2 boxes twice. It's now twice as far. I'm going to put a new dot. I'm going to do the same for B. So here, originally I had to go up 2 over 5, so now I need to do that twice. Up 2 over 5, up 2 over 5, put a new dot. From P to C, I had to go down 2 over 5, so now I do it twice, put a new dot. And from P to D, I had to go down 2 over 1 twice, put a new dot. Then you're going to connect your new dots. That is the size of your new shape. So that shape is our image where we were dilated from center P and we had a scale factor of 2. Now it's your turn. Pause the video. This time, dilate the same shape with center P, but with a scale factor of 3. Your shape should look like this, taking up most of the grid. To get here, you should have drawn your imaginary lines. A had to go up 2 over 1 3 times. B had to go up 2 over 5 3 times. C had to go down 2 over 5 3 times. And D had to go down 2 over 1 3 times. Let's look at a different shape. So here, we're already given the imaginary lines drawn for us. This time, T, our center, is outside the shape. So we still drew lines from T through each vertex, each corner of the shape, and I want to dilate with a scale factor of 2. So originally, from T to S, I had to go down 2 over 2. Now I need to do that again, so it's going to be twice as far. To go from T to R, I had to go down 1 over 4. Now I need to do that twice, so it's twice as far. T to Q, up 1 over 3, twice. Draw your shape. Now we have a new shape with a scale factor of 2. Notice when the center of dilation is outside the shape, your dilation is also going to be outside the shape. Whereas in the previous example, we saw the center of dilation was inside the shape. When we made our dilation, we made the shape inside a shape. Now it's your turn. Pause the video and see if you can figure out what the dilation of the triangle looks like with a scale factor of 1/2. Let's check. Your shape should look about like that. A scale factor of 1/2 or anything between 0 and 1 makes it smaller. So you needed to make each corner half as far as it was to begin with. Next, we're going to look at what's called similar figures. So we want to know if these quadrilaterals are similar. And how do we know? Well, similar figures just mean that they're dilations of each other where everything was multiplied by the same scale factor. So thinking about the examples we just did, taking one shape and dilating it, we multiplied how far away it was from the center by the same number each time. And so we were multiplying everything by the same scale factor. So when we want to check if things are similar, we need to know, are they multiplied by the same scale factor? Let's start with 2 to 4. What scale factor was it multiplied by to go from 2 to 4? Well, it must have been multiplied by 2. So if these are similar figures, then everything must have been multiplied by 2. Well, 6 to 18 was multiplied by 3. Even though it might not look like it, this shape actually got 2 times taller, but 3 times longer. So it wasn't dilated correctly. It is not a similar figure. Okay, so one side was dilated by 2, the others by 3. Because they're not the same scale factor, they are not similar. Now it's your turn. Pause the video. Are these two quadrilaterals similar? How do you know? Let's check. You should have found that yes, they are similar. Each side was dilated by a scale factor of 3. 3 times 3 is 9. 10 times 3 is 30. So it was dilated correctly. They are similar. Another thing that we can do using similar figures is to figure out missing side lengths. Again, because things are similar, everything had to have been dilated by the same scale factor. If it tells you they are similar, then you know that to go from one shape to the other, they must have been multiplied by the same thing. So if I want to go from the small trapezoid to the larger trapezoid, I would multiply by 2 because 9 times 2 is 18. Or if I wanted to go from the large one to the small one, I could have multiplied by half, or thinking in my head, divide by 2. But division's not used for scale factor, it's multiplication. So multiplying by half is correct. So if we know that it's either multiply by 2 or multiply by a half for one of the sides, that means it has to follow the same thing for the other. So x must have been multiplied by 2 or 5 times a half. Calculating this out, that would mean that x must be 2.5. That way they stay similar and are dilated correctly. Now it's your turn. Pause the video. What is the missing side in the similar figures? Let's check. You should have found that x was equal to 5. Here, I noticed that if I go from 5 to 25, I'm multiplying by 5. So to go from 1 to x, we'd also need to multiply by 5, so x must be 5. Or you might have noticed that 25 times 1/5, or divided by 5, gives you 5. So x times 1/5 gives you 1. Still x is 5. In this lesson, we learned about a fourth type of transformation that's not rigid because it changed the size, but it produces what's called a similar shape that's just larger or smaller. So here the word similar does not just mean they look alike, but they actually have the same angles from the pre-image to the image, and then all lengths are just multiplied by the same scale factor. When we're dilating a shape from a specific point, you draw guidelines from the center through each vertex or the corners of the pre-image. Then you make the vertex for the image also on those lines, but multiplied based on the scale factor. Scale factors greater than 1 will enlarge the shape, while scale factors between 0 and 1 will shrink the shape. Remember, when you're doing these, the shape looks like the original, just larger or smaller. We also use those for similar figures when we're calculating unknown sides. The fact that they are just dilations of each other means that they had to be multiplied by that same scale factor. So after this lesson, do you now know how to draw a dilated shape, especially ones from a specific point? And can you calculate unknown side lengths of similar figures based on a scale factor that would take the dilation from one shape to the other? If you're not sure about those things, go back and look at the examples of how to draw a dilated shape or how to figure out an unknown side using the scale factor. And that's the end of Lesson 8 on dilations and similarity.